Hi everybody, it's Kyle again at Oasis Digital. Today I'm going to talk about a very different topic than I've really ever talked about on a video before, CycleJS. I'm going to talk about some how and why and my experiences with CycleJS. If that sounds weird, that's because most of what you've seen from me here at Oasis Digital has to do with Angular Bootcamp, because most of the time in my day job, so to speak, I am working with Angular, building complex enterprisey things. But every once in a while I wander to a new technology, and today that new technology is CycleJS. So let's step into it here. Don't need our website, don't need that website. Okay, so CycleJS, certainly there's a lot of great stuff here to read. I suggest reading this stuff. I suggest trying it live. I suggest going to YouTube and watching any video you can find that introduces CycleJS. There's a lot of great stuff out there which I'm not going to try to reintroduce here. Instead, today I'm going to try to get into my experiences using this thing and kind of what it feels like. And why I think there is some legs to this kind of different approach that Cycle takes. The project I'm going to be looking at for that is this one. I'll just leave the URL up here if anyone wants to see it. I might remember to paste it in the description or maybe not. But you can take a look here and I'll show what commit I'm on. So if you see the code I'm looking at, you can see it's this commit right here. So there might be some newer commits depending on if I make some more adjustments here, but this is the exact code that I'll be looking at. If you scroll down in here, if you bring this up, there's a link to the application running. So this little application I'm going to look at today is running right here on the web if you feel like playing with it online. But I'm now done pointing that out, don't care about that, because I have it running locally. So this is my local one because I want to be able to make some edits to it while poking at the code and explaining some things. So now that we're situated here, you've seen where to get this code I'm looking at. If you run it, you'll be able to run the same thing I'm running locally. To do that running, here I'll hit Control-C here, all I did was I did an npm install, which I don't need to repeat, and then an npm start. To make that work, I used a thing called CreateCycleApp, which I believe is right here. So CreateCycleApp is there's this sort of not quite family. There's a bunch of things called Create blah blah app. So there's Create React app. There's a bunch. There's CreateCycleApp is the one I'm using. This is just some nice bit of tooling that makes it easy to get started. It's sort of a CLI for launching and running a cycle application. The exact details here don't matter. The important thing is that I'm using a thing that they call the one-fits-all flavor, or sometimes it's referred to as the one-size-fits-all flavor. They used to have this idea of different flavors of CreateCycleApp, and now they've sort of tried to consolidate to just a single one that does everything that most people want. Okay, so npm start. Here we go. I've also brought the code up here in Visual Studio Code. Visual Studio Code, of course, is a great IDE for working with TypeScript code, and I'm doing all of my cycle in TypeScript, so that's what I'm using. Okay, so let's start looking at features. So here is the beginnings of a screen. This is like Cycle app, and this first screen here is static. There's no behavior of any kind. Now there's some stuff off to the side that I'm going to kind of gloss over for a moment, and I'm going to explain essentially the world's simplest cycle component. Right? So if you don't know what a cycle component is yet, go back, you can watch some videos, you can read the introduction, but I'll be talking about exactly what it is practically in the code in a moment. So I have numbered my directories so that they stay in the order I want to talk about them. I found that's a great little tip when you're building example code that you want to explain in order, even though these would be terrible names in a real application for the folders that each part of the application is in. They're great names when you're just explaining. Okay, so here we go. Here is, okay, so message is just some static text that I wanted to pull out of my component because I didn't want my component to have 29 lines of static text. So here's an extremely simple cycle component. I have some TypeScript imports that we'll gloss over for the moment. Message MD, this is just getting the text from that adjacent file. I've brought in this thing called Showdown, which is a way of converting Markdown to HTML, because I didn't feel like typing out this long message in HTML, so I typed down in Markdown, then I brought in this thing called Showdown that I can use to convert it. So here is my simplest cycle function, my simplest cycle component. A cycle component is a function. That function takes an object, which is a collection of sources, returns an object, which is a collection of sinks, both of which are, roughly speaking, a bunch of observable streams. So it takes sources, which are some kind of object. I didn't bother to type it. I didn't care any more than that because it doesn't actually use the sources. It returns some sinks. It only returns one sink called DOM in the world of Cycle. The way you put stuff on the screen is your component returns a thing called DOM, and that is supposed to be an observable stream of virtual DOM. So here I have a function that returns a stream of virtual DOM, and I'll explain each piece here in turn. This code is just getting ready to use that showdown markdown to HTML converter. So the actual cycle part is just this part. So we're saying XS, we'll explain that in a moment, of, so this is a way of saying make an observable that just always returns this value. Div means generate the virtual DOM corresponding with a div in the DOM, and then pass it some properties, one of which is inner HTML, and for the inner HTML, pass that HTML I just created. So this is a very concise way of saying, go run that markdown converter, get me the HTML, and let's make a component that just returns that HTML. Now, of course, I could have consolidated this more. I could have inlined this view function. It seems to be something of a well, not quite, maybe a de facto standard in the Cycle world to split out your view as a separate function, so I went with that. Now, I've glossed over a bunch of things here. This first line, this import xstream. So for complex reasons that I will not try to explain here, it made sense for Cycle to have a simpler, more concise, kind of more minimalistic observable implementation than the mainstream observable implementation. So for example, you've probably heard of RxJS. I've used RxJS, highly extensively over in the Angular world. I've even used it over in the Angular 1 world, before Angular 2. I've used it with Node, so I'm very familiar with RxJS. But nonetheless, I picked up Xstream, which is an alternative, kind of considerably simpler observable implementation that's kind of optimized for just what you care about in Cycle. And I don't think I need to point anything else out there, simply that in the code, it exports its kind of main function as its default, so you say import XS, then it imports a type corresponding to a stream with the word stream. So you have to use slightly unusual import syntax. It's not clear why they didn't just let us do it in here. It's not clear why they chose to export that as a separate default top level thing, but almost all code ends up doing this kind of a slightly funky import. So this part doesn't actually depend on Cycle. Xstream I don't believe has any dependencies. It's a great little standalone observable library. Works real nice. vnode and div, these both come from Cycle DOM. So if you're at all familiar with React and its virtual DOM, this is just their virtual DOM implementation. It's actually based on a thing behind the scenes called SnapDOM. And SnapDOM is this kind of, I guess, started out as kind of a niche alternative virtual DOM implementation, but it's really got a lot of legs. In fact, I think I read that Vue.js, yet another competitor in this space, actually uses a fork of SnapDOM itself. So this SnapDOM thing is really nice. It's wrapped up in a kind of ready-to-consume form in Cycle from CycleDOM. So all I needed in here was this vnode type and then this div function to make the vnode div. So I think I've now explained all this code. So down here, so in Cycle, again, a Cycle component always accepts a set of sources, returns a set of sinks, and then those sinks are typically observable streams. So here we go. So Vue returns an observable stream of vnode. So this is just a way of saying put this on the screen. So basically all the code you've seen here corresponds to this long screen here. And again, I'm glossing over how the routing part works because that's probably the most complex and subtle, and I might not even get to that in this video. I might have to make a series of videos to build up to that point. Okay, so now we've seen how sort of the simplest reasonable Cycle component works. Now it's not really the simplest. I could have just hard-coded a little bit more HTML in here instead of doing this funky thing where I brought in the text, but I didn't want to make it as trivial as like a if you read the introduction, you kind of get the very most trivial. So let's move on to my next component. So to see this component in action, so here we go. I have the same stuff at the top. So the stuff on the side and top, again, I'm ignoring that because I'll have to get to that later of how that came in. And I'm sort of saying ignore the overall application structure and just look at a component in isolation. It's sort of easier to understand a component isolation before you understand how the components wire to the whole world. So here we go. It looks like I'm just putting 3 components on here, or 3 instances of the same component. I've called it a color chip, and it looks like it has a name, so some text to display, and some kind of color code. So like if I was coding this in Angular, there would be an @ component, and there'd be an @ input for the label, and an @ input for the color code, and that sort of thing. So let's see how we do something analogous to that, just a basic component that takes some static inputs. Let's see how we'll do that in Cycle. Okay, so a few more bits as they come along the way. This is a TSX file because you can write TSX, which is just the typed version of JSX, and it's I'll take out some superfluous space here. It's totally fine if you never want to use TSX. It's also totally fine if you want to use a mix of TSX and plain TypeScript. I've chosen to do that just to get maximally familiar with all the variations. And so we'll get to code in a moment, but if you like your templates to look a little more like HTML, that facility is available. It's not in any real way Cycle specific. It's just sort of off the shelf, supported by almost all the tooling out there. You can do JSX, you can do TSX, you get types. This is just basically an HTML-like alternative syntax for TypeScript. Okay, so setting aside the funky naming, let's look through the code again. Now, this chips component, which corresponds to the screen, this uses a thing called a chip component. And that makes me think it's probably best to understand the chip component first. So here is a chip component. So again, it's just, here I can probably use the dev tools to highlight what part of this thing is a chip component. Probably right there. So that is a chip, that's a chip component, right? So it consists of a label and then a little block with some color in it. Okay, so in Cycle, a component is a function that accepts some sources and returns some sinks. So here is my component. I've exported it because I want to use it from elsewhere, and it accepts some sources and it returns some sinks. So the sources it accepts, I've chosen to give those types because I really like TypeScript, and what it accepts is DOM. Does it actually use DOM? Let me see here. I'm trying to see if it actually uses DOM. I might be able to simplify the code right in the midst here. It does not. So it accepts DOM, but it doesn't actually use DOM. That means that I actually do not need to import that. So let me make sure that the program still runs. Yep, still works. Okay, so the reason I chose to fix that midstream is it lets me use this code to make a great point. So something that Cycle really gets right, really just totally nails, and I'm very eager to see some of the other kind of bigger frameworks compete with this aspect of Cycle, is with Cycle you can almost always discard what you're not using and boil your components down to kind of the bare essence of what they really need. And so here, my chip component, the only thing it cares about the sources. So the only data flowing into this component is this props thing I've defined. It doesn't care about any of the rest of the world. So I didn't even need to import that stuff. So I don't have any accidental dependencies on anything I'm not using. Cycle is really good at letting you guard your dependencies and boil down your components to like the bare minimum boilerplate. Okay, so my chip component takes some sources. That source consists of a stream of props. Now, why is it a stream? That's because like the fundamental idea of Cycle is this, streams going between the user and the software, or streams going between an outer component and an inner component. Cycle is all about essentially streams and virtual DOM. In fact, if you take many of the other libraries out there and you imagine, what if I got rid of almost everything in this library so that all that was left was streams and virtual DOM. If you just boil almost anything down to streams and virtual DOM, you'd end up with something pretty close to Cycle. But that's come up as I've been working with Angular quite a bit recently. Angular, of course, it's a vast framework with highly numerous features, one of which is observability, which they do with RxJS. And yeah, I mean, it often feels like in Angular, there's many ways to do things. There's the more reactive way with RxJS, and there's like less reactive ways. Whereas when you look at something like Cycle, basically all the other ways have been thrown away. The only way to do pretty much anything is with reactivity, observability, and in this case, Xstream, you could use RxJS. So let's say that I want this chip to accept some inputs, some numbers to define a color and a string for a label. With Cycle, you don't go pick up a new component feature to do that, right? So there's like no toolkit of how like you're not using some pre-existing specific mechanism to solve the problem of data flowing into the component. Data always flows with observable streams. That is the answer to basically to every question in Cycle is, how are we going to do this in Cycle? Well, we're going to use reactive streams. So if I want some properties, some input data to flow into my component, the answer, like there's no negotiation, there's no discussion, there's really even no thinking about the answer. The answer is always, well, the data is going to come in or go out using reactive streams. So I just went ahead and made that happen. So the sources this thing accepts shall include something called props, and that's going to be a stream of these things. And so I simply defined the set of inputs I wanted to my Cycle component using a plain TypeScript interface. And I feel like this is a real strength of Cycle in that, unlike, say, React, Angular, Vue, to name three really popular ones. So unlike all of those that have went off and defined their own mechanism for how you would like group some incoming data to a component, Cycle simply skipped all of that and said, well, you already have TypeScript and you already have reactive streams, so let's just use those. And that's what this code does. And so it takes a little looking to understand exactly what's going on, but the great thing is there's nothing Cycle going on in this code I have highlighted. So my chip simply accepts those sources. Now, I want it to render this, so let's find out how we render that. Well, I wanted to make this thing work even if the caller didn't provide one of these, so I did this default prop mechanism, but I'm going to ignore that for now. That doesn't matter. Fundamentally, all this chip does is it takes the properties that someone passed into it as a reactive stream, and it returns a reactive stream of virtual DOM for what should be rendered. So those words are probably really confusing if you're not familiar with this stuff yet, but once you get familiar, it's very, very concise, and the lack of any kind of external complexity around that is really, really brilliant. Okay, so my view function then that I'm just calling right here, and again, the only reason I split this out is because that's sort of a de facto standard in the Cycle world, is to make your view a separate function. So I want the thing I display here to be a function of what that input was, and when you want one thing to be a function of another, with some of that, in fact, I think all of the libraries and frameworks, there's like a special way of accessing these inputs. Like, how do you get those? Well, with Cycle, it's just functions, and so if you want that input information to be available to the view, the very low-tech solution is you simply pass it as a parameter to the view. So there it is. So the view gets a stream of these things. Now, if I have a stream of data and I want to make a stream of different data, I actually don't need any Cycle thing to do that, right? So again, I'm not really doing anything Cycle right here. In fact, the only Cycle I have in the whole thing is that I want to be able to use these functions to define virtual DOM. I'm not using any Cycle like up to that point. So I take these incoming properties and I just want to transform them. Well, you transform a stream with map. So I take those and I map them, and once I'm inside the map, I now have the actual props instead of having a stream of the props. So this map function is how I get from the observable, potentially infinite series of changes to I have a value in front of me and want to work on it. And so now I'm just going to return some virtual DOM. So everything you see on these highlighted lines should be exactly analogous to what you could do with React or any of 50 other frameworks, libraries built on virtual DOM. So I want a div, and inside that div, I want a P and another div. Inside the P, I want a span that has some static text, followed by another span that has some text that came from the incoming properties. And then in the div, which is the color chip, there's this mechanism to define your styles these are dynamic styles. They're coded in the code here instead of in a global CSS file. And so there's a syntax to do that where you say style, and then these things sort of correspond. And this seemed like the simplest way to get an RGB. There's probably some better, cleaner way to handle turning these numbers into a color, but this worked. So, okay. In fact, you know what? I will make a tiny format correction. That really should be like this. So some of the libraries you may have used, there's kind of some mangling going on, or like, well, you'd have to know that you'd say background cap C color. We don't do that in Cycle with SnapDOM. Just literally the string here, the key is exactly what you want the style to be in CSS. There's no translation going on. Okay, so again, this is the sort of second simplest kind of component you could make. So the first simplest kind of component was just a completely static component. The second simplest type of component is a component that accepts some input properties, and its appearance depends on those properties in some way, but there's no user interaction or anything. So I think we're going to call that enough for this part 1 video, because it looks like we're up to 21 minutes, and I found that nobody wants to watch more than about 25 at a time. So we'll pick up with the next one on how we compose a bunch of these chips together to a set of chips on a single screen. So thanks for watching, and please click the subscribe button down there so you don't miss any future ones. Bye-bye.